Alright, so this is the final project for Dr. Osbe. We'll be using XFLR5. I'm doing part 1, the rectangular wing with different aspect ratios, but for the purpose of the video, we're only doing the aspect ratio of 10, and my name is Nicole Ringel, and I'll be showing the tutorial throughout. So, open XFLR5. Blank, we're going to go to module, we're going to go to direct foil design. This is just the default that shows up when you open XFLR5. Just click show, no show. I chose it not to show. So for our specific foil that's directed in the project, we're going to go foil, NACA foils. Ours is 2415. And the number of panels, a good number would be 250. Press OK. So that's our 2415 NACA foil. We can choose to show the center line. We can also choose to change the picture, change the width, change style and variations along the lines for extra visual analysis or something like that. Okay, so from here we're gonna go to module. We're gonna go to XFoil direct analysis. From there we're gonna go to analysis batch. From here this is going to show an analysis between different types of Reynolds number. Doing a little bit of calculations, we can do insert right after 3 million and choose the Reynolds number to be 3,300,000. Perfect, and that falls before 3 million and after 3 million and right before 6 million. So that was our Reynolds number that we're going to get for these rectangular wings. And then polar type is going to be type 1. That's also fine. In the project, the angles of attack would be -5 to 15 degrees and increments of 1. From 0 should be deselected. And then that should be good for the batch analysis. We're going to click analyze. Make sure to select your NACA foil up there, and we're going to click analyze. Shouldn't take too long. Perfect. We're going to close this, and then we're going to go to plane. Where is he? We're going to go to wing and plane design. And then from there, we're going to define a new plane. And this is where we're just going to select the wing. We're going to deselect elevator, unselect fin. We're going to define the wing. For this, the aspect ratio is 10. Chord length is 1. We can change that really quick. Offset should be 0, 0, 0, 0. Foil, or NACA foil. So for the aspect ratio of 10, the Y will be 5 because it's split in half. It's split in half in the axis, so it's 5 to the left side of the x-axis and 5 to the right side of the x-axis. And here you can also double check right here where it says aspect ratio 10, which that matches up. Wingspan 10, everything adds up here. We're going to save, and then we're going to save. Perfect. And then we're just going to right click on it, analysis, define an analysis. Type 1, fixed speed is fine to use. The velocity in the project says it's 50 meters per second. And then we're going to go over to analysis, and LLT is fine. LLT theory will be the ideal one to use here. And then for the analysis of that, we're going to just make sure it's selected on the type 1. We're going to go here to sequence. This was already here from my previous project simulations. Angles of attack, -5 to 15. Delta, which is increments of 1. We're going to click Analyze. And these are the graphs that we're going to need for the project. So CL versus alpha. This one, CL over CD versus alpha. And then here is CD versus alpha. And then this is the Oswald's efficiency over alpha. To change the graphs, you can double click and then choose the variables of which you want, of which graph you're trying to find. It's pretty simple. Scales, grids, but yeah. Here are the variables you can switch around, and then to export, I just right-clicked, export results, save, put it into Excel, create your own graph, compare it to make sure it looks like the ones simulated here on XFLR5, just to make sure. But yeah, those are the 4 geometry graphs needed. After we get all the plots needed, we're gonna go to this graph right here. This will be for the part where it's asking for a 5-degree angle of attack, and you have to find local lift coefficient, induced angle of attack, and then induced drag coefficient. So it's asking for a specific degree, which is 5, so we're gonna press this X right here to just deselect everything, and 5 is right here, so we're gonna go select it. Here we can reset graph just so it looks nicer throughout. Here is where the graph is. So this one is induced angle, and then to get the other ones, you just double click again, like the previous graphs. We're going to do lift coefficient along the wingspan, and it'll be that. And then to get a better visual for that, we can do reset graph. But I think that's how far it goes. So that's the local lift coefficient, and then for the induced drag coefficient, right here, this would be the graph for the induced drag coefficient along the wingspan as well. I believe that is all for this project, but pretty simple, pretty straightforward. This was for the aspect ratio of 10 for the rectangular geometry wings portion of the project. Thanks.